Hi there, my name is Mark, and we are going to be solving this system of equations using the substitution method. We're going to be finding the values of x and y that make both of these equations true simultaneously. Now, I've given each of these equations a label. I've called the first equation EQN1 and the second equation EQN2. And that's going to enable me to set up my three-step process. I'm first going to take equation 1 and change the form of that equation so that I get x is equal to some expression in terms of y. I'm then going to take that expression, substitute it into equation 2, getting a value of y that I will then substitute into equation 1 to get my value of x. So let's slow that down and let's start with equation 1. So the first thing we need to do is take equation 1 and change how it looks. We need to change its form. So I'm going to start off just by writing out the equation. I'm going to write it in blue so that we can connect it with equation 1, and we're going to start solving this equation for x. So the first thing I'm going to do is add negative 4y to each expression, and that will leave me with 3x is equal to 2 plus negative 4y. Now what I'm going to do is divide each expression by 3, leaving us with x is equal to 2 plus negative 4y, and that is going to be also divided by 3. Let me just clean up that left expression there and that equal sign a little bit so it looks a little tidier. There we go. Now, what I'm also going to do to make the next step a little bit easier is just to decompose this fraction into two terms. So that's the same as 2 over 3 plus negative 4 over 3y. So I get to see that coefficient of the y term. And essentially what we've done here is we've changed the form of equation 1 so that I have x is equal to some expression only in terms of y. And that is going to lead us into step 2, where we're going to be considering equation 2. And this is where we are going to replace that variable x in equation 2 with the expression we just obtained for x in equation 1. So replacing x with 2 over 3 plus negative 4 over 3y. And let's not forget that term of 3y. So we get plus 3y and then equal to negative 1. Using the distributive law here to expand, we get 2 times 2 over 3, giving me the product of 4 over 3. 2 multiplied by negative 4 over 3y gives me the product negative 8 over 3y. Plus, well, that is 3y, but I'm going to rewrite that 3 as a 9 over 3 coefficient. And now you can see that we have a common denominator throughout that left expression. In fact, let's change that 1 to a 3 over 3. So I have a common denominator of 3 throughout my equation. Next, I'm going to go ahead and simplify that left expression by collecting those like terms of negative 8 over 3y plus 9 over 3y and adding them together to give me the sum of 1 over 3y. Continuing forward to solve this equation, we are now going to subtract 4 over 3 from each expression. That's going to leave me with 1 over 3y is equal to, and actually let's just write this out, 3 over 3 minus 4 over 3. And now we need to go ahead and evaluate that right expression. So we still have our 1 over 3y in the left expression, and 3 minus 4 gives me a sum of negative 1 over that common denominator of 3. Now I have a fraction equal to a fraction, so I'm just going to use some cross multiplication to speed up the solving process here. I'm going to take that factor which is in the left expression's denominator and express it as a factor in the numerator of the right expression. And our denominator is still 3. The product of negative 1 and 3 is negative 3. Divided by 3 gives me a value of negative 1. We have just found the value of y, which is now negative 1. Moving into the last step, moving into equation 1, where we are going to substitute that value of negative 1 to find the value of x. Notice that I'm using the changed form of equation 1. Now you could use the original equation 1 form, but it's going to be much easier to substitute a value of y into this form because then we can evaluate x directly. Let me show you what I mean. So we have 2 over 3 plus negative 4 over 3. I'm now going to replace that variable y with the value of -1. Now, -1 is an integer, so why not just express this as a rational values, so as a fraction, and then I can just go ahead and multiply those numerators and denominators. I see that I now have a common denominator of 3 for these two terms, so that will leave me with 2 plus 4, because -4 times -1 gives me the product of 4, and that's all over a common denominator of 3. 2 plus 4 is 6, divided by 3 gives me an x value of 2. And we are done. We have now found the values of x and y that satisfy both of these equations simultaneously. Let's just go ahead and express this as a solution set where we have the ordered pairs here where the x value is 2 and the y value is -1. Now I'm going to move into GeoGebra to check our result. Step 1 is to enter the first equation, and GeoGebra will automatically assign this equation object to the name EKV1. I'm going to change the color of this to match our algebraic solution, so that would be the color blue, and maybe I can make that line a little bit thicker for you to see on your display. Next, I'm going to enter my second equation, and again, GeoGebra is automatically going to assign this equation object to the name EKV2. Once again, I'm going to change the color to match our algebraic solution, which was red, and maybe make the line thickness a bit thicker as well. Now, in exam.net, you just can't click on the intersection point to get the ordered pair. You actually need to provide it the function intersect, which has 2 arguments, which are the names of both of our equation objects, so EKV1 and EKV2. And this will return the intersection point, which is 2, -1, which is the solution to our system of equations. My name is Mark. Thanks for watching.